So good afternoon to everyone. So today we are going to start the session with the series connection of PV panels. Okay. So now when you have the symbolic representation of an solar panel is a box like this, and we are indicating the terminals as one as positive and another as a negative. Okay, so one terminal we are indicating as a positive and another one we are indicating as negative. This is one solar panel. This solar panel is going to have a maximum voltage of Vm, and this is going to have a maximum current of Im. Okay, so if you want to increase the voltage, then I want to connect like this two solar panels in which connection? Series connection. Very good. Okay, we need to connect these solar panels in series connection if my array voltage is required more. Okay, so this I have two panels. This voltage is of the solar panel is Vm, the current of the solar panel is Im. Okay, I have two solar panels, I want to connect them in series. So how to connect them in series? The negative terminal is connected to the positive terminal, and what are the ultimate terminals you are going to get? One is positive, one is negative. So here I am going to get a positive terminal, and here I am going to get the negative terminal. Okay, so now I want to calculate how many solar panels are connected in series connection. So that's also very much important. So you will get the problems on that, how many panels are connected in series. Okay, so we are doing all the series connection only to enhance current, but current remains same. Okay, let's try to find out the formula. So we are going to call this as a V maximum, I mean maximum voltage of the array. So maximum voltage of the array is equal to maximum voltage of the solar panel multiplied with number of panels that are connected in series connection. Ns represents number of panels connected in series connection. For example, you take this, how to understand this problem is, for example, I have a solar panel. Let us take it is of 12 volts. What is the voltage? I mean maximum voltage of the solar panel, 12 volts have been taken, but I require the array voltage as 24 volts. How much voltage? 24 volts. I am multiplying each solar panel with x times. How many times? With x times. When I multiply it, how much you are going to get? 24 volts is the array voltage divided by individual voltage is how much? 12 volts. 12 ones are, 12 twos are. You are going to get x is equal to, or ns is equal to how many? 2 number. It indicates that two solar panels are connected in series connection. So that's what the formula, how to calculate the number of panels connected in series. The formula is maximum voltage of the array. Array means, what is the meaning of array? So actually we have solar cell, the group of solar cell, when you connect them, it is called as a solar panel. Group of solar panel, if you connect them in series connection, it is called as an array. In array, you will have some panels may be connected in series or they may be connected in parallel. Okay, so actually when you connect these panels in one configuration, we will call this as a string, and this group of strings we will call it as array. Okay, so all this why you are adding means only to build up the required voltage of the system voltage. Let's try to see this problem. So the maximum voltage of this system we are calling as V maximum of the array, maximum voltage of the array. So the current which is developed at the output of the panel is called as I maximum of the array. So IMA is the maximum current of the array, VMA is the maximum voltage of the array. Okay, we need to calculate all these two. So now we see here, what is the voltage at these two terminals? Vm. What is the voltage of these two terminal? Vm. Sir, how to calculate this? Okay, so let's try to, we are more professional with electrical engineering, we'll try to apply the which rule? KVL rule. Okay, so I'm taking two solar panels of this configuration are connected in series. This is one panel, this is a Vm, and this is also Vm, and we require VMA. Okay, this is the current I. Okay, so already the terminals are given to us, positive, negative, positive, negative. Now try to apply KCL. So when you apply the KCL, we can get the maximum value of the array. So try to apply Kirchhoff's voltage law. So current is leaving. What is the leaving polarity? Plus Vm. What is the voltage? Plus Vm. And current once again is leaving. What is the leaving polarity? Plus Vm. and current is entering at positive terminal and current is leaving, and we need to get what is the leaving, what is the polarity of the array, minus VMA is equal to 0. So the algebraic sum of voltage sources and voltage drops are 0. Okay, that is already valid. So now Vm plus Vm is how much? 2 Vm is equal to VMA, where VMA is called as which voltage? Maximum voltage of the what? Array. This is the maximum voltage of the array. Okay, so now what is the maximum current? So in a series connection, current is same or different? Same current will flow. So whatever the current is flowing here, which is nothing but Im, the same current will flow in both the panels, and you are going to get Im. So therefore the maximum current of the array IMA is equal to how much? Im. For the two panels what have been taken, this is acting as a first panel, this is acting as an second panel. So what is the output values of the array? VMA is equal to how much now? VMA is equal to how much? This is 2 VM, and IMA is equal to how much? IM. Is it clear? So this is how to calculate the resultant voltage of the array, which is 2 VM, and resultant current is IM. So now let's try to calculate the maximum power. Okay, shall I rise? So now we taken two solar panels of which rated? Same rated or identical rated. So now we are doing the calculation. When you have a two solar panels of same rated, same means 100 watt peak, where the same rating we are going to call it as ideal rated or identical rated or same rating. So if you connect two solar panels of same rating, what is the maximum power of the array? So maximum power of the array. So what is the maximum power of the array? Maximum voltage of the array multiplied with maximum current of the array. What is the maximum voltage of the array? What is the maximum voltage of the array? Already we calculated 2 into Vm. What is the maximum current of the array? Im. So I can write down this is 2 into Pm. Therefore the maximum voltage of the array is 2 times Pm. So when you connect the two solar panels of 100 watt peak, which are called of same rating, power is multiplied how many times? 2 times. The power is scaled how many times? 2 times the power rating is increased. Okay, so what is the rating of this panel we have taken? 100 and 100. Now what is the rating of the resultant array we will get? 200 how much? Watt peak. Yes or no? So now we are going to get 200 watt peak. So this is how to calculate the number of panels. Okay, for example, if you are interested to calculate the number of panels which are to be connected in series connection.